Your AI is hallucinating future code into your legacy stack, and it's killing your sprint. Stop the drift. Today, we're building a hard systemic firewall to force GitHub Copilot into total enterprise compliance. Let's lock it down.
This data stream represents the baseline state of GitHub Copilot, a natively modern AI trained on bleeding-edge syntax, frameworks, and modern architectural paradigms. Drop that modern engine into a restricted, older enterprise ecosystem like .NET 4.7.2, and the system grinds against its constraints. This interface shows what happens next, a phenomenon we call temporal hallucination. The AI aggressively injects unsupported, future state syntax into codebases that cannot process it. Instead of accelerating feature development, developers spend their time reverse engineering invalid suggestions, hunting down syntax that simply does not exist in their environment. Without active intervention, an unconstrained AI in a legacy environment drives architectural drift and corruption. Taming the AI requires a systemic solution, the Copilot-Instructions.md governance file. Placed directly in the repository root, this markdown file is automatically indexed by the Copilot service across the entire codebase. The file acts as an invisible constraint matrix. Watch the blue prompt node flow toward the LLM core. It is intercepted by the red firewall, forcing the AI into deprecated constraints, stripping away modern biases before data reaches the LLM. Deploying this file elevates Copilot from a chaotic code generator into a system governed by automated, repository-level compliance. Governance is useless unless it intercepts the daily developer workflow automatically across every interaction point. The first interaction point is Vector 1, Inline completions, the real-time suggestions known as ghost text. In this 3-lane pipeline, inline data packets hit the central filter, turning green. Next, chat queries absorb specific rules from the barrier, generating tailored, proprietary responses. Finally, large-scale code generation builds instantly, strictly confined within a glowing boundary box. By intercepting all 3 vectors natively, the system ensures developers cannot accidentally bypass enterprise legacy constraints. Building these guardrails requires specific rules, starting with Pillar 1, Legacy Guardrails. For an older enterprise project, the absolute mandate is restricting all AI output exclusively to C# 7.3 and .NET Framework 4.7.2. This split-screen terminal shows the mechanical impact. Left, modern C# 12 syntax is heavily crossed out. On the right, standard C# 7.3 code is validated in green. The AI is mathematically blocked from injecting modern asynchronous concepts into synchronous routines. Next is Pillar 2, Library Locking. Allowing an AI to invent its own dependencies creates massive security and stability risks. The instructions apply direct mandates, expressly banning Newtonsoft while strictly enforcing the use of system.text.json. Explicit negative constraints tell the AI exactly what do not do, stop it from guessing, and force conformity to the authorized enterprise package list. Explicitly locking the framework and libraries neutralizes the 2 most common causes of AI-induced build failures. Moving to Pillar 3, a sprawling repository requires total uniformity in its test suites. The instructions mandate this uniformity by forcing the AI to always use mock for unit tests, explicitly forbidding alternatives like n-substitute. As these neon geometric blocks snap into a rigid grid, we see Pillar 4, UI and architectural consistency. This is often the hardest concept for an LLM to master natively. An AI cannot infer deep internal corporate design patterns simply by reading a few open code tabs in your editor. The solution is commanding the AI directly. The instructions stipulate that all newly generated UI forms must inherit from specific proprietary base classes, like shared page view. A secondary architectural mandate requires developers to extend data row base classes, forcing the AI to adopt the company's established internal habits. Implementing these 4 pillars aligns the AI's output with corporate standards, regardless of the developer's seniority. This governance model has one primary vulnerability, a physical limitation known as the context window trap. The LLM operates with a finite token budget. It physically cannot process an infinite list of enterprise demands all at once. This vertical scroll illustrates middle-of-file blindness. Top and bottom glow, the middle fades to static, ignoring central rules. We extract formatting rules to an editor config node. The primary document shrinks and glows uniformly, reserving instructions strictly for logic. For massive repositories where front-end and back-end teams require entirely different rule sets, Architects use split brain. By using YAML apply to properties, local instruction files are deployed to specific folders, isolating rules just for the test directory, for example. Relentlessly managing the AI's token budget is as critical as writing the rules. Efficiency guarantees compliance. Once deployed, an architect must verify that the containment field is successfully holding. The definitive behavioral check for AI compliance in a legacy system is known as the adversarial test. This logic gate schematic demonstrates the methodology. We intentionally prompt Copilot with a request that violates project rules, like asking for a modern feature in a restricted project. Watch as the red data packet attempts to pass through the constraint filter node and is instantly deflected. The pass criteria is strict. The AI must refuse the prompt or automatically self-correct, explicitly stating it is restricted to the mandated legacy version. Passing the adversarial test proves the instructions are functioning as a hard systemic firewall, rather than just polite suggestions. Architectural boundaries have been codified, the token budget managed, and the firewall thoroughly tested. Compared to the chaotic data stream we started with, this glowing digital fortress represents our new reality. The AI now perfectly mocks tests, extends proprietary classes, and outputs legacy code. This rigorous application of governance addresses the temporal hallucination problem by restricting the AI's logic to the project-specific era. The operational mindset is clear. This instruction file must be owned, versioned, and updated by a tech lead, just like production code. Mastering the Copilot-Instructions.md file bridges the massive gap between bleeding-edge AI capabilities and the uncompromising realities of enterprise legacy systems.
Stop letting your AI guess, start commanding it. Own your instructions, version your rules, and bridge the gap between bleeding-edge tech and legacy reality. The fortress is built. Now, go deploy it. For more deep dives into AI governance and enterprise optimization, subscribe to TheAIUpdatePro and hit the bell icon to stay ahead of the curve.